the diagrams being drawn accurately all the time. In this case, it looks like it's reasonable. For example 6, we're going to solve for the unknown sides. So I'm going to find side A first. To find side A, actually let's find the angle first, because that's going to be the easiest. So this angle is complementary, so it's going to be 61 degrees, complementary to 29, so we subtract from 90 degrees. Side A then, we're going to use at 29 degrees, opposite hypotenuse is sine. So I'm going to write this as sine of 29 degrees is equal to opposite over hypotenuse. In this case, I have the angle. What I need is a ratio to solve the problem for A. So I'm going to use sine. So sine 29 gives me 0.4848. So I'm going to round that to 485. So 0.485 to 1. We don't really need the 1, but we just want to make sure that we understand that's still a comparison. Solving for side length A is going to be 4.85. Okay, so I'm just going to write that in, 4.85. Now, once I have two sides of a right triangle, I could use Pythagoras. Okay, and that's perfectly fine. And we have options here, but I'm going to choose the option of using a ratio. So this time I'm going to use cosine ratio. Cosine of 29 degrees is adjacent, which is B, over hypotenuse, which is still 10. To solve this, I have the angle, I need a ratio, so I'm going to use cosine. Okay, the cosine function gives me a cosine ratio of 0.8746, so I'm going to round that to 0.875. And again, we don't have to write the 1 in there, but remember that is a ratio. It's a comparison to 1, and that gives me a side length of B of 8.75. Okay, so that if I use Pythagoras, I should get about the same amount. We may be off by a few decimals, just a decimal because the rounding that might be introduced in our solution, but we don't need to worry about that. So we'll do the same thing for B. We're going to work out the angle first. It is complementary, so it adds up to 90 degrees. So 90 minus 65 gives me the 25 degrees. I have one side. I want to find another side. So I'm going to start with side B. And that I can use either angle, but I'm going to use angle 25. And I have opposite, adjacent, TOA. So that's tan. So tan of 25 degrees equals opposite over adjacent, or rise over run. So I have the angle, I want a ratio, I'm going to use my tan button. Tan 25 gives me the ratio of 0.466 to 1. Okay, so the height is about 47% the adjacent side B. I'm going to cross multiply to solve for B. So I end up with 5 over 0.466. And working that side length out, 5 divided by 0.466 gives me 10.72. Okay, so this length is 10.72. Okay, so last time I found the third side using a trig ratio. This time I'm going to just use Pythagoras to find the third side, C. So I'm just going to change my pen color here. I'm going to call this side C. And I'm going to use Pythagoras. So to do that, I'm going to end up with 5 squared plus the side that I solved for was 10.72 squared is equal to C squared. Okay, so we might be off by a little bit based on the rounding, but if we don't round, we'll get a very accurate answer. So 10.72 squared plus 5 squared gives me 139.797, so C squared is equal to 139.797. So C, when I square root this, I'm not going to keep it in exact values because it's already in decimal values. And so when I solve for C using Pythagoras, I get 11.83 as my length. So that's going to be 11.83. And that looks pretty reasonable based on the side length and angles given.